Let us now see some applications of references. So let's take a look at these two programs. In both the programs, we have passed parameters by value, right? That's the default way of parameter passing in C++, right? If you don't put references, they're passed by value. What are the disadvantages? First thing is changes are not reflected. Let's understand the point. So in this example program, what I've done is I've created a variable x and then I passed it to the function fun. Now I'm trying to change the variable x inside the function fun, and then I'm printing x in the main function. When I print x in the main function, I get the same value 10. Why? Because this local x2 function main is different from this local x2 function fun, right? They are different x. They both have value 5, but they are labels to different memory locations, right? So if you make changes here, these changes are to this local variable x, and these are not reflected to this label here because this is a label to different location. So if you want to write a function that changes parameters, you cannot do this with pass by value, normal pass by value, right? And there are many situations where we would want to do this. For example, if you want to write a swap function that takes two variables and swaps the values of these two variables, right? So if you simply do x and y passing and try to swap the values, and then when you come out of the functions, value would not be swapped. So swap function cannot be written by simply using pass by value. This is one problem. The other problem is when you have large objects. For example, if you have a large string, due to the limitation of space, I have not used that large string, but strings can be large. So if you have a large string and if you pass it by value, what happens in pass by value, a copy of the object is created. So this string S and this string S, they are different objects, right? And all the characters are copied to this. A new object is constructed here, right? Which is performance issue, right? So there are two issues with normal variable passing, right? Normal pass by value. One issue is changes are not reflected outside the function. The other issue is performance issue. Both the issues can be resolved with the help of references. Here I have modified both the programs, and in both the programs now I am using reference. So if you take a look at this function prototype, I have put ampersand here. So what happens now, this x, when you pass it, this x and this x, they are alias to the same memory location, labeled to the same location. So if you make any change here, the changes would reflect in this x also, right? So now if I print x, I am going to get 15, right? Similarly, I can write a swap function that takes x and y, right, as references and changes the values of x and y, and this way we can swap, and or any other function where we want to change the past parameters. So this problem solved. Let's now see the second problem. The second problem is also solved by simply passing the string as a reference, right? So now when you are calling this function with s parameter, a new object is not created. This s and this s, they become labels to the same memory location. Now you might be wondering why I have written const. This const is not mandatory, right? This program would work. Your problem will be solved without const also. The purpose of const is for better readability of the program. See, here our purpose of using reference was to modification to the parameter. Here our purpose is performance optimization. So when your intention of a function is to improve the performance by passing the reference, you don't want to unintentionally modify this string, right? You're just using reference for performance reasons. It's better to use const.